Hello, hello, my fellow mathletes, and welcome back. We are looking at question number 16, and we are right in the middle of the 2007 Fermat paper from I just said 2007 from the University of Waterloo. These fine folks at the CEMC. What have we got? In the diagram, each of the three squares has a common vertex. Each of the three squares, I skipped a line, has a side length of 3. So there's 1, 2, and then A, B, C, D is the third one. Okay. Two of the squares have a common vertex, O. And O is the center of the square labeled A, B, C, D. The perimeter of the entire figure is closest to. Well, I've got a 3 here, some 3's here. And then we have these little extra bits. So 6 3's, that's 18. So 18 plus a bit. And these bits don't look particularly big. So, I'm guessing each one of them maybe 0.5, 0.6. I got 4 of them, so that's about 2. So, 21, 22, that sort of thing. So if I had to guess, I'd say A or B just by looking at the picture. But, that's not how math works. Let's draw the picture here and see what we can see. I'll draw it a little bit bigger so we can really focus on this. Alright, so we'll draw these guys first. And then, so O is the center, and then we have A, B, C, D here. Doesn't have to be exact, doesn't have to be perfect. It's your picture, or in this case, it's my picture. As long as I understand, all these things are supposed to be squares, as long as I understand, all these lengths are the same, we're fine. So, I think it went A, B, C, D. It doesn't really matter, the lettering right now. But what have we got here? So we've got sort of right angle. I'm going to use a different color, green, let's say. So we got a right angle triangle when we're talking about this OAB here. And we know AB is 3. So we've got a right angle triangle side length 3. But OA, well, that's the center. And this is the key part. O here is the center. Center to A. It's going to break this up into a 45 and a 45 here. Same reasoning gets us a 45 over here. And now suddenly I've got an isosceles right angle triangle. Okay? And if we're not familiar with these, they do pop up a fair bit. They have side lengths in the ratio 1 to 1 to root 3. So that's, not root 3, root 2. So if I know one of the side lengths, I can talk about the other side length and the hypotenuse. The flip side of it is if I know the hypotenuse, divide by root 2, and I will get the 2 legs. Well, this time I know the hypotenuse. So these fellas here are 3 over root 2. 3 over root 2. Now, how's that helping me? Well, if we take a look at these red lengths, they're going to be the same, and a nice little symmetry argument will carry that through. But these red lengths plus these legs form the full side of 3. So this guy here is the side 3 minus the 3 root 2. Or sorry, 3 over root 2. Okay? And I've got 4 of these. So we have the full 18 from 3, 3, 3, 3, 3, 3, plus 4, 3 minus 3 over root 2. Alright, so that's going to be 18 plus 12 minus 4 over root 2 is 2 root 2. 3 times 2 is 6, so 6 root 2. And I will have 30 minus 6 root 2. And we can either grab a calculator and work that out, and that's fine. Calculator's going to go just fine. 30 minus 6 times root 2. And we're all set, 21.5. Okay. But, say I forgot my calculator. Well, one of the things that's pretty good to know in case you are someone who forgets your calculator are nice things like, pi is 3.14. That can do in a pinch if they're asking you a circle question, you want the area or length closest to. Other nice values to know, especially because they come up on grade 10s and 11 papers with trigonometry, are things like, root 2 is about 1.41. 1 over root 2 is about 0.707. Root 3 is 1.37. Root 3 over 2 comes up a whole lot because of trig is 0.866. These are things that either you do enough math contests and you start to know them, you play around with your calculator enough, you start to know them, or there's something you say, gee, I tend to forget my calculator a lot, or I'm really worried that on the big day I will forget my calculator. There's some nice common numbers that it's good to know decimal expansions out for the first 2 or 3 digits, because they come up a lot in these sorts of questions, in the what is this length closest to? What is this area closest to? Okay? So, root 2 is about 1.4. How about we just very quickly try to do the question with that? So 6 times 1.4, well, I'm going to rearrange it as 1.4, and 6 there, 6 times 4, 4, carry the 2. Yeah, a calculator's faster, but I forgot my calculator. So 8.4, 30 minus 8.4, 29, and then the 10, so we get a 6 here. 29 minus 8, 21. 21.6. Knowing that the real answer is, 21.514, that's not bad. And for this question, that's certainly good enough. It's got to be A. There's no other way around it. So there we go. We can either approximate because we know these things, or we remembered our calculator and we're off to the races. But 30 minus 6 root 2, or 20.5, that's going to be our answer. Okay? So that was, what was that? That was question number 16. So off to question number 17 in the next video. I will race you there.